Problem 35, we have it's an application about the radial and tangential acceleration in the case of rotational motion. What we have here, the this figure, as we see, A equal 15 amp per second square represents the total uh, acceleration. A is the total acceleration. This particle is moving clockwise in the direction of the clockwise in a circle of radius equal 2.5. So at this time where the object is at this point, find the radial acceleration. Okay, let's discuss before about this position. We saw before, now we need to calculate part A, we need to calculate A radial. You know, by calculation, A radial is equal to minus V square over R. R is the radius of this circle, this one, equal 2.5. Okay, and V is the magnitude of the velocity. So V is the magnitude of the velocity square. Is a speed. You can say it's a speed. Now the question is, let's draw on the figure the components of the acceleration. You know, at any point, as you see here, the velocity is in this direction. So the A tangent, it's like this. So this one is A tangent. Okay, as the velocity increases, A tangent takes the same direction with V. And A radial must be directed toward the center. This one is A radial. You know that you can write here the unit vector AR and ER and ET. Here you have ER unit vector, and here you have ET unit vector. Excellent. Now we know all about everything about the directions, about AT, AR, ER, ET, and let's go to calculate and we do the calculation. To calculate A radial, uh, if you have here A, okay, we can calculate A radial geometrically. You look here, we can by this triangle here. You know that by using this triangle, AR is the component. Here we have angle equal 30 is given. So cosine the angle equal AR divided by A. Okay, cosine the angle equals the adjacent angle divided by the hypotenuse A. So cosine 30 equal AR over A. So A radial equal A cosine 30 equal A equal 15 times cosine 30 You can use your calculator to calculate this one. The final answer, it will be 13 m per second square. Good. This is the answer. Now, so we can write here a radial equal 13 m per second square. Maybe we cannot use this one. Why? Because we don't have the value of v. If if we have the value of v, we can use this equation because r equal 2.5. Okay. Uh, Now part B, find the speed of the particle. The speed of the particle, it means we have to find this value. This is the speed. To calculate the speed, we use this equation. So the speed, okay, we can use here. Why the negative sign? It's just the direction. Okay, let me talk here about the negative sign. You can say here AR vector equal minus V square divided by R. Here you have AR, it's opposite and opposite direction to ER. So AR is a minus ER. Okay, like I and J. I and minus I. J minus J. AR is in this direction, but ER is in the opposite direction. You can write like this, or you can write as magnitude equal V square divided by R. So V square equal AR times capital R. We calculated AR equal 13 times R equal 2.5. So V equal radical 13 times 2.5. The answer is 5.7. 5.7 m per second. This is the value of V. 5.7. Now it's okay. I want to write here the value equal 5.7 m per second. Let's erase to have more space to continue the solution. We have to find the tangential acceleration. To calculate the tangential, we can use one equation. Okay, if you say a tangent equal dv over dt, can you calculate at? No, because you don't have the expression of v in terms of t. You don't have this expression, so we cannot use this equation to calculate at. The only method to calculate at is a equal at square plus ar square, or a square equal at square plus a radial square. So a t square equal a square minus a radial square. So a tangent equal radical a square minus ar square equal a square equal 15 square plus AR equal 13. We get the final solution equal 7.5 m per second square. Okay, uh, now uh, I think it's all. The answer. Okay, thank you.